Akmal bin Muhammad Razi. I'm from DKA 4A. For my metric number is 16 DKA 18F 1109.
My name is Muhammad Anwar Faiz bin Adnan from DKA 4A. My metric number 16 DKA 18F 2997.
Assalamualaikum. My name is Muhammad Zahid bin Sudan. My metric number 16 DKA 18F 299C.
Hi, my name is Muhammad Adil bin Muhammad Tajudin. My metric number is 16 DKA 18F 2015.
Assalamualaikum. I am Muhammad Shazmin bin Muhammad Rizwan. Metric number 16 DKA 18F 2045.
Hi, Assalamualaikum. My name is Hati Rosna and my metric number is 16 DKA 18F 2060.
Hello, my name is Naamira Binti Rostain. I'm from DKA 4A. My metric number is 16 DKA 18F 2056.
For the chapter 5, hydrodynamics. For the first point is flow visualization. Flow visualization is in fluid dynamics is used to make a flow pattern visible in order to get qualitative or quantitative information of them. Many methods have been developed for making flow visible. Most methods include experimental method like spilling into water. For the second point is dye injection method. The method is employed in a water tunnel or water channel. The method is introduced dye by injection tube needle to the location of interest in the flow field.
15. So my part is all filler method. So all filler method is the content is the method is to apply some resource fixed mix with solid powder whose color is easily visualized by eye. On the tested model, having had the model in the test section of a water channel subject to a desirable speed, the pattern revealed by the oil film provide the information of flow near the model surface. Example, limiting streamline pattern which implies the shear stress pattern. So the next I will explain about the hydrogen bubble technique. Hydrogen bubble technique is the technique consists of using the bubble produced by the electrolysis of water as a flow visualization tool. Using a fine wire mounted perpendicular to a wall, the cathode or negative electrode in a circuit and another material such as a brass as the anode or positive electrode, the production of hydrogen occurs on the produce. So the wire is designed as the cathode because the hydrogen bubbles generate they are approximately half as large as oxygen bubbles produced there and serve better as traces of the flow due to their smaller volumes.
First, streamline. It is useful to visualize the flow pattern. Line join points of equal velocity. These lines are not a streamline. Here are 2D streamlines around a cross section of a aircraft wing-shaped body. Flood the following past a solid boundary does not flow into or out of the solid surface. The direction of the streamline is the direction of the fluid velocity. fluid cannot cross a streamline. Streamline cannot cross each other. Any particles starting on one streamline will stay on that same streamline. Real and ideal fluid. Flowing real fluid exhibit because effect have a stress when their body. From airline topic, we saw this relationships between shear stress and velocity gradient. The shear stress in a fluid is proportional to the velocity gradient. Meanwhile, in an ideal fluid, the effect of the shear stress due to boundary are not. Fluid is assumed to have a viscosity. That's all.
I'm here to present about classification of fluid flow. Fluid flow may be classified under the following heading. First, uniform flow. Flow conditions are the same at every point. Second, non-uniform flow. Flow conditions are not the same at every point. Steady flow. Flow conditions may be different but do not change with time. Fourth, steady flow. Flow conditions change with time at any point. Then, combining these four given: steady uniform flow, steady non-uniform flow, unsteady uniform flow, and last, unsteady non-uniform flow. Steady uniform flow is a condition do not change with position in the stream with time. For example, flow of water in pipe of constant diameter at constant velocity. Second, steady non-uniform flow. Condition change from point to point in the stream but do not change with time. For example, flow in the tapping pipe with constant velocity at the inlet. Third, unsteady uniform flow. At a given instant in time, the conditions at every point are the same but will change with time. For example, a pipe of constant diameter connected to a pump pumping at a constant rate which is then switched off. And last, unsteady non-uniform flow. Every condition of the flow may change from point to point and with time at every point. For example, wave in a channel.
Next point is compressible or incompressible flow. All fluids are compressible so that their density will change with pressure, but under steady condition flow, provided that changes in pressure are small. We usually say the fluid is incompressible and it has constant density. However, in unsteady flow conditions, high pressure differences can develop and the compressibility of liquid must be taken into account. There are in general three types of fluid flow in pipes. Okay, first laminar, second turbulent, and third transition. Okay, laminar flow generally happens when dealing with small pipes and low flow velocities. In laminar flow, the motion of the particles of fluid is very orderly with all particles moving in straight lines and parallel to the pipe walls. In turbulent flow, vortices, eddies and wakes make the flow unpredictable. Turbulent flow happens in general at high flow rates and with larger pipes. Transitional flow is a mixture of laminar and turbulent flow, with turbulence in the center of the pipe and laminar flow near the edges. Each of these flows behave in different manners. In terms of their frictional energy loss while flowing, and have different equations that predict their behavior. Okay, next is Reynolds number. Reynolds number could be used to predict the change in flow type for any fluid. This was first investigated in 1880 by Osborne Reynolds. Okay, in Reynolds number, there are 3 discharge. For the first one is low discharge, and then medium discharge, and the third one is high discharge.
So I will explain the formula for the chapter 5. So we use the RE equal rho VD per U, or RE equal VD per V. So you can see here the formula. So you can use for the exam. So you saw the question. So this is question 2 is the example of the question. So you can study with this slide. Thank you.